Hey guys, it's Simon and welcome back to the LibGDX RPG tutorial series where we are already quite far in our development. So we have already game loading where we can control a player. We have some collision objects. We introduced Box2D. We used Tiled as our game editor. And we have some animations. We have some background music. We have sound effects when we press the space button, where we are currently still missing the attack animation, but that will be added in a future part. And in this part, we are going to focus on a very important topic, which is Scene2D, the user interface part of LibGDX. And this is the first time where I'm quite confident and also happy to show you how I work nowadays with Scene2D, because in the last tutorial series, it was always a programmatic approach for me and very annoying to develop a user interface for my game, because we will come to that in that part. Certain things like how to position the elements correctly was always a try and error approach and very time consuming and not a lot of fun, with some debugging lines for myself to help the development. And nowadays I use a program which is called Skin Composer. I showed it then in this part, developed by the awesome guy Releus. I would suggest to check out his YouTube channel as well, because he makes a lot of very good Scene2D videos and in general LibGDX videos. Awesome guy. And yeah, with that little tool, it helped me personally quite a lot to develop user interfaces in LibGDX, and it's way easier than it was in the past. But step by step, so how does Scene2D work? So let me do it again similar to Box2D via code. So we will update our game screen for now. And the core class of Scene2D is called a stage. A stage is basically a so-called scene graph. So from what I know, that's simply a data structure, how you can store objects which are linked to each other. And in Scene2D, the stage uses a so-called scene graph where you have a root element, and the root element can then have multiple childs. You can imagine that the contents of a stage are then like a button or a label or a progress bar or a group of these widgets. And in Scene2D, they are called actors. So a stage, let me show that here below. A stage has a method to add an actor. And an actor is, as mentioned again, it's a button, a label, whatever user interface element you can imagine. And they are stored in a so-called scene graph. So this is how that works. And yeah, so how do we initialize a stage? So we can create a new stage. There is just a normal constructor, and that one takes two arguments. That is the one that we are going to use. One is the viewport, and the other one is the sprite patch. So if you would not supply the sprite patch to the stage, then it would create its own sprite patch, similar to what we had with the tiled renderer, with the map renderer. But since we already have a sprite patch available, then we can simply reuse it. We don't need a separate sprite patch object. And the viewport, that is something important, because I personally, and also I see a lot of other beginners out there, they usually start to use the same viewport for the game and for the user interface. But in our case, you can imagine that really doesn't make a lot of sense, because our game viewport has this arbitrary world units, which is simply currently a 16 by 9 world. And a 16 by 9 world, when it comes to user interfaces, you normally use pixels there for the graphics and for the interface in general. So we would only have 16 times 9 pixels available for our user interface. That does not make sense at all. Also, could be depending on your game, as we have learned with the fit viewports and so on, that maybe you will have some black bars at the left, right, top and bottom, but maybe with the user interface, you want to stretch it over the entire screen. And yeah, to summarize it, or in short, I suggest, and this is also the suggestion from other developers out there, game developers, make a different viewport. So don't mix up your game viewport with the user interface viewport. There you should really have a separate one. And yeah, for that, in our screen here, we can create a new viewport that we can call UI viewport. And for the user interface, what I used in the game screen at least, that was a fit viewport with the size of 320 by 180 pixels. And that is the one that we pass to our stage. Also, usually I create a stage per screen, because again, the viewport here could be different in the game. Maybe I want to have a smaller resolution because the user interface elements that I have in the game are a little bit different than, for example, in a main menu screen, where maybe I want to have a bigger viewport because I display also the banner of the game, maybe some other elements which simply take up more space. So that's why nowadays I usually create a stage and the viewport per screen and not globally for the entire game. Also, it's a little bit easier because you will see that then later on, we will add these so-called actors to the stage, so the different buttons, labels, and so on. And if you use the same stage throughout the game, you always need to take care to correctly clean up and initialize the stage every time for each screen. And yeah, when you have it just limited to one single screen, then in my opinion, it's a little bit easier to understand what is available and what is happening with your stage and how to control it. Good, so now we have a stage available. We could already, as we have seen before, we could add those actors, which would be, for example, just to give you an example here, a button, or as I mentioned before, a label. So there are different actors available in Scene2D. And then, of course, we need at some point that the stage needs to render the user interface. And yeah, how does that work? So let me jump to the render method here. And after we have rendered our game, here we can then apply our user interface viewport so that the next thing that is going to be rendered is linked to that specific viewport. And then from our stage, we get the patch and we set the color to color white. Also, just as a safety measure here again, in case the game would be rendered in a different color and maybe we end up here with a red color or something, then we don't want our user interface to get tinted in that specific color. So we set it back to white. And then there are two methods. One is called act, where we pass in the delta, and the other one is called draw. So the stage, the Scene2D stage, has two phases, let's call it like that. One is the act phase, where we come to that also later on, where you can, for example, add animations to your buttons that they are rotating or maybe they get bigger. And those are called actions. You have seen that before. When I entered add A, there is add actor and also add action. So you can assign certain actions to an actor, which would be, again, like for a button to get bigger or to rotate or change its color over time or fade out a certain element in the user interface. And all those things which are happening or happening over time, that is happening in the act method. So basically, or easy to remember is maybe that it simply updates all the actions that you have added to your user interface. And draw, that one is then simply the render part of the stage, which then renders all the actors that you have added to your scene stage. Good. What else do we need? So when we hide something or when we hide our screen, then here from our stage we call the clear method. That simply removes then all the actors which were added to that. And in the show method, so now it's the first time where we use our multiplexer. So we also need to add our stage here to the input processors. Why is that? Because a button, for example, in a user interface, you can click on it, or maybe a text input field that you can input some text. And for the stage to react to all these events, so to this keyboard and mouse events, it obviously needs to react to the input events. And that's why we need to add the stage as an input processor. And again, the order might be important. In our case, it doesn't really matter. But in our case, the stage gets the input events from LibGDX first, and then the keyboard controller gets the events. This is if we define it like that. We can, of course, add the stage after the keyboard controller. Again, in our game, it doesn't make a difference, but maybe if you want to have here some exact behavior or what to control when is what called, then you can do that here as well. Good, then later on here, we will add the code to add some actors to the stage so that we see something. And finally, there should be a resize method. We didn't use that yet. So we need to override the resize method here because, of course, we want to have the normal resize behavior. But in addition, we need to update our UI viewport with height. And also we want to center the camera all the time because usually the the user interface gets rendered relative to 0, 0, which should be the bottom left corner. And by centering the camera, we exactly have that behavior. And finally, in the dispose method, and that's the last thing that you need to remember with a stage, there is then also a dispose call in the stage. And that, just as an example, I don't know what else it does, but it would clean up the sprite batch again, similar to the map renderer. If it would have that, then it clears the stage, so it removes all the actors. And if you would have the debugging of the shapes, I also showed that in that part, where you then see where the elements would be rendered, what is the actual size, and what is the visual representation with the graphics and so on. There, it seems like it would also clean up some debug shapes, which is a shape renderer, and that one we have already seen in the Box2D debug renderer. So the stage also uses here then some rects, lines, and so on, so some simple shape rendering for debugging. Good, and before we start now designing our user interface, I simply want to show the credits here again. I use the user interface in essentials here. Should be again a link to itch.io, and there I use this user interface essentials, and I cannot remember which ones because there is a couple of different variations of the user interfaces in there. And yeah, I used one of those for dialog boxes, progresses bars, for the selection indicator, and so on. And yeah, that is what we are going to use for our user interface. And yeah, just for you, so for now, to continue with that part, from the assets raw folder, there is a user interface folder, and then simply download all these assets. And I will explain then step by step how we use them. Also, what is that .9, what is a TTF file, and also in the root project itself, what is this scene composer file here. And that is the next part that we are going to cover. But for now, simply whatever user interface graphics you want to use, just create a new folder in UI and put the graphics and the font files in there. So I have done that now. So I created here this UI folder in objects and put in all the assets from the repository. And yeah, how does that work in Scene2D and in the stage? So you could imagine, as mentioned before, you have the different actors like button, label, progress bar, text input fields, and so on. And somehow it needs to know how a button should look like. So what is the graphic when the button is released? What is the graphic when the button is pressed by the user? For a checkbox, how should it be represented when a checkbox is ticked and when it's unticked? For a label, what kind of font should it use, with which color, and so on. And all these configurations, so how things should look like, what kind of resources they use, that is stored in a so-called skin. You don't need to use a skin with Scene2D. You can create everything programmatically, but in my opinion, it makes sense and it's the best practice to use a so-called skin. A skin is again some JSON file format, which then tells the stage or Scene2D how a button looks like. So for example, what is the background graphic, or for a label, what kind of font should be used, what kind of color should be used. And when it comes to the classes itself, so let's look, for example, at the label class of Scene2D, then every actor has also a style class in it. So a static class, which is called for the label, it's a LabelStyle. And there you have the configuration like the font that is used, the color for the font, and a background graphic. Or another example for the Scene2D button, there is a ButtonStyle with the graphics for when the button is up, down, when you hover over it with the mouse, when it's focused, when it's disabled. So there are a lot of different configurations. And the skin file basically creates then all these style classes, so a LabelStyle or ButtonStyle, and sets the correct properties for each of the style fields or elements that you want to use. And the skin then gets used in the stage. So when you create a button or a label, then Scene2D looks up in the skin what kind of styles does it have there available. Styles are stored per string. So there's always a default style, but you could also have multiple styles for a button, of course, maybe a large one, a small one, a special one with an icy theme in wintertime, something like that. And yeah, with the skin name or with the style name, you look then up the style properties in the skin file, and then the button or the label, for example, gets rendered with the specific configuration. And yeah, creating that skin file manually would be, of course, very tedious, and also the user interface creation would be very annoying. And that's why we are going to use a program that is called Skin Composer. I add the link to the video description below. It's this one here, again from that guy Relius. And there just downloads the latest release here. There would be a jar file, for example, for Linux user, a tar.gz file. And yeah, then just run it, or download it first and then run it. So for me, I have downloaded it here in my development folder, and I've created a specific batch file in Windows which runs java-jar skin composer jar, because I cannot double click it because it opens it, I think, with 7-zip or something. And yeah, for some reason, changing it to running it as a Java file didn't work out in the end. So I just created that batch file. And that's it. So this is how Skin Composer looks. You most likely also have I would need to check that somewhere, but you most likely have a welcome screen that you can enable and disable. So for me, it would be under project settings. There is a show welcome screen. I have unticked that, but for you, the first time when you start it, you most likely also have a welcome screen, which has some guidance and documentation how to use it. But don't worry, I guide you through the most important functions that we need for this part. Okay, so how does it work? So first of all, we are here in the Skin Composer part. There would be also different areas of this program. There is one which is called Scene Composer. There we are then creating the main menu user interface in a moment. And there would be another section which is Texture Typist Playground. I covered that in another part. That one is a very awesome label utility which allows you to add very cool effects to a label, like a jumping effect or this ghost hollow effect or fade in, fade out, rainbow color effects, a lot of different things, but we covered it in a future part. For now, we just focus on the Skin Composer area. And there you have, as in the drop down here, you have the different actors available in Scene2D. And by the way, sometimes I might say widget, but for me, actor and widget, it's the same. I use that independently. Here it's called a class, and there you see the different actors which are available in Scene2D, like button, checkbox, a label, an image button, a progress bar, a split pane, and things like that. And let's select, for example, the button. Then you see here there is a style, and as mentioned before, there's always a default style available. For every actor, you should have at least one style, which would be the default style. You don't have to create a style. So for example, if you don't use text tooltip or if you don't use the touchpad, then of course you don't need to create a style there if you don't use it. But if you use an actor, then you should specify at least one style, which is called default here. And here, for example, let's say we want to set the up graphic of the button. So we click here, and then we get to the drawables area of Skin Composer. And there we can now add the different images that we want to use in our skin. So all of the things that we are defining here, this then in the end ends up in the so-called skin that I have explained before. So let's add a graphic, and we want to add here an image file. Then let's go to our Mystic tutorial YouTube, assets raw, user interface. Oh, I put that under objects. That's actually wrong. Let me fix that. It should be out there. It should be below objects. Okay, fixed. So it's now separate outside of the UI. And there, let's pick the button graphic here. Okay, so we see now here there is a texture available. Now we click on that texture, and now it's selected for the up graphic. And on the right side, we already see a preview how that would look like then when we use it in our user interface. We can change the stage color. So there you also see the stage name again that we have introduced before. Let's take, for example, a black background color. If we would have that for our stage, then it would look like this. But the default color here is the white background. And then you can have different representations. So how would the button look like when it's large? How would the button look like when it's growing on the x-axis? How does it look like when it grows on the y-axis? It looks already quite bad with those things, but there we introduce something in a moment where we improve that. And yeah, that would be the default size. And in the end, so now let's just save that. So first of all, save as. That would be this Scene Composer file, so scmp. Let's store that in the YouTube folder, and let's call that skin, for example. So now we have saved all the styles that we are going to create, all the different fonts, colors, drawables, and so on. All of that is now stored in that Scene Composer file. And to create a skin, we could now click on Export, tell it where it should store this export file. This also gets stored in the Scene Composer file. So let's go to Assets. Let's create there a new folder that we call UI. And let's call that skin. Then generate a texture atlas, copy font files, copy TFG files, and so on. Minimal JSON format, and let's click on Export. So there you see some summaries or some warnings if we haven't defined certain styles for certain actors. But as mentioned, if you don't use it, then you can simply ignore these warnings. And now back in our assets folder. So there you see now we have a skin JSON file. We have a skin atlas. That's it. So this is what Scene Composer is then exporting. And the JSON file looks very easy. So currently we have defined this ButtonStyle class that I've shown before. There we have a style which is called default style. And that one has for the up graphic, for the up graphic of the button, it uses this button texture. So this is how that is stored. And the atlas itself currently just has this button graphic with the information we already know that from the texture atlas part, and the PNG file, which currently also just contains the button in the end. And yeah, so there you might wonder, first of all, how does it create the atlas? Because if you remember from that part, you might want to set there some settings with the filtering of the graphics, how the size of the atlas should be. And yeah, you can go in Scene Composer to settings there. And there you can open the texture backer settings for the file export, and also the texture backer settings for the file preview inside the program itself. And for the export, you get then guided to your user folder, .scene composer, texture factor, yada, yada, yada. And there you have then this file that we also used already for our texture backer tool. And there you could adjust, for example, the filtering. I used here again nearest instead of linear. You can define the padding, the bleeding iterations, and yeah, things like that. So this is already known from the texture atlas part. And yeah, here you can configure the settings, and they are then stored in your user profile. And yeah, coming back to the button. So if you might want to have a different style, then you can simply click here to new style, give it a new name. So for example, I don't know, Christmas style, and then define a new style with a different up graphic. And if we would save that, then our skin file, the JSON file, simply would have then another entry for the Christmas style. So this is, in general, a very basic introduction how this tool is working. Good, then let's continue and let's create a label, because a label has something which is called a font. And with a font, there are two different font types that you could use in your game. One is a so-called bitmap font that would be create FNT. What that is, you basically select a font file, could be again a true type font file. You tell it what kind of characters it should export. So default, just the numbers, A to C. Maybe I always need to do that because I have some German translations as well. I need the special characters here as well in German. And in the end, what you get with a bitmap font, you get then a texture which contains the different characters that you want to have in your font with a specific size, also with a specific effect for borders, shadows, whatever, and an additional FNT file. And this is, in my opinion, very similar to a texture atlas. This file then tells that, for example, the capital A is at that specific position, takes up that region, or the lower A takes up that specific position and region. And yeah, it has then there some glyph information. And when it comes then to text rendering in LibGDX, it uses then the texture, so this bitmap texture, and extracts the different characters out of it to render then a text to the screen. The benefit of that is that this bitmap font texture that you get, you could also pack that inside your texture atlas, for example, together with the objects. And then if you would render text and also objects, you don't have a texture swapping or texture binding, because the font itself, so the different characters, would be part of your object's texture, as an example. But we are not going to use that because, in my opinion, the bitmap font has the disadvantage that it's very static. So you define here your configuration once with the size, shadows, and so on, color and everything, and that's it. Then you have the texture with the different characters in it, and you can use that. So you cannot quickly change, for example, the size or give it another effect or something. That is not so easy then with a bitmap font. And for every change, we would need to open up this file, change the size and everything, and export everything again, which is a little bit annoying. And in my opinion, better solution for that is to use a TrueType font, because there we don't create these bitmap fonts and FNT fonts files up front. There the content or the textures and everything are created dynamically. So when we load up then a TrueType font with a specific setting, then all the necessary things like the texture and so on, they are created on demand in the game and can then be simply used. This has, of course, the disadvantage that we have additional texture bindings when we render text, but it has the advantage that we are more flexible and don't need to re-export everything again when we play around a little bit with the text settings. And yeah, so font name I used there, how is it called? Cherry Soda something? Yeah, Cherry Cream Soda. This is, I think, a Google font which has no copyright or license issues, so you can simply use it. So let's call it, let's call it, for example, I don't know, Cherry Font. And yeah, so what do we need to do? So we tick this checkbox here. So use custom serializer to enable the buttons here. And then we can browse to our FNT file. Which would be this Cherry Cream Soda, regular here. Then for the characters, for now, we just export the default characters. But again, if you need something more advanced, I usually pre-fill it with that. Then it exports the lowercase letters, uppercase letters, the numbers. And then in the end, if I need also some German letters, and if I want to see in the preview here if it's working, then I just add that here as well. Then the size of the font, which should be used for previewing and everything. So there, let's set it to, for example, I don't know, 16. A color. So whenever we want to render some text, it has to be with a specific color. And there, I always use white, because white has the advantage that we can also dynamically change the color of text in LibGDX, and also later on with this typing label. And if the text is white, then it's very easy to also make it red and brown. If the text is initially red, for example, then you cannot make it white, because there's no color combination that you can make a red color then in the end white, for example. So that's why starting with white makes it easier to then tint the text later on. So we choose that here as our default color. And then there are some other options like border, shadow, whatever. You can play around with that. And yeah, in the end, you see the preview here, how it would look like. You can also change the text here. So this is some test text. There I can also try out the German letters, for example, if they are rendered correctly. If this font somehow would not support that, I would simply see here some boxes that it's not correctly rendered. And you can also specify here the filtering, which would be, for example, I don't know, you can change that here to linear for the text. Maybe it looks then a little bit better and smoother in our game. And yeah, once you are done, then I suggest to save the settings, which is a Scene Composer font file, which could be, for example, I don't know, Cherry Cream settings. Because then later on, if you maybe want to have another text version with different effects or whatever, or different border, then you can load up these settings and you don't need to remember them. Yeah, and in the end, we click on Generate Font. And now we have this Cherry font here available. That is our TrueType font. And when we click on that one, we end up finally back again on our label, where if we would render now some text, we would use this Cherry font TrueType font. And yeah, we don't see anything here in the preview because the stage color is white and our text color here is also white. We could change that here by adding a new color to it. Let's call it black. And then we see here the text. But for the default style again, we don't want to have a specific color, so we simply clear the color here and have our white color. We could also, of course, change the stage background color. Then we also see here the preview of our label style. And yeah, so let's save the skin composer file again and let's export it once more. And now coming back to the project, we see first of all that the TrueType font file that we used got copied as well, because that's then needed in the game when we load the skin, that we use the correct font file here. Also our the atlas didn't change. We didn't add any new graphics, but in our skin JSON file, there we now have some additional information in it, like the color objects that we have. Then we have our free type font generator with the settings that it should use. Then we have the button style, the label style, and maybe because I clicked on text tooltip, I cannot remember, that also created now this text tooltip default style. So this is in general how skin composer and the skin file generation works. One final thing, or one more thing that I want to show now is with the button. So let me go back to the button here, and you see here that the button, let me also change that back to a white color. When we change the size to, for example, a large button, then it looks kind of stupid because the original graphic that we have gets stretched simply to fit the space that we need for that button actor. And there is a very easy strategy to solve this scaling issue with textures, which is called a 9-patch. So when we go back to our drawables here, then we can click on Add and create a 9-patch file. The image that we are going to use is again the button. And then let's just click to Auto Patches. And here in the preview, maybe let me revert that again to the settings that we had before. Makes it easier to explain. So right now in the preview below, you see when we change the size of this graphic, it simply gets stretched and looks a little bit stupid, of course, if a button would look like that, if we have a very huge button. And to solve that, we can use so-called 9 patches, where you have, in total 9 patches of a graphic. And let me again click on Auto Patches. So you have one patch at the top left, top center, top right, then in the middle, you have 3 patches, and at the bottom, you have 3 patches. And now you already see that when it comes now to scaling and resizing. So how does it work? From what I remember, the corner patches, they are not getting stretched at all. So they stay as they are. And the parts which are getting stretched is then the edges here, which then looks way better than stretching everything. And also the centerpiece, or is it just the centerpiece which gets stretched? Looks like it's just the centerpiece then actually which gets stretched. The top and bottom part most likely just gets stretched from left to right, but not in the height. The left and right patch gets stretched from top to bottom, but not in the width. And the corner cases or the corner patches, they don't get stretched at all. So this is at least how it looks like. And this is called a 9 patch. So that helps, or that solves the stretching issue. And when we save this now, then you see it automatically adds this .9 to the end of the file name. Okay, then we need to select it again here for the button style, because we removed now this normal drawable or image and now replaced it with a 9 patch. And there you already see now, so even if you have now a large button or a small button, it always looks at least better than before. So it doesn't simply get stretched anymore, the entire graphic. Now it gets stretched in a specific way using this 9-patch approach. Okay, and this 9-patch approach might sound like the holy grail, the solution for everything when it comes to scaling, but there is one specific issue, and there we're going to need to introduce a slider. By the way, because I was confused there is a progress bar and there is a slider. And in the main menu, we will have this slider where we can change the volume of the music and of the sound effects. And a progress bar doesn't allow an interaction. So if a user clicks there with the mouse, then the progress bar doesn't react to that. The progress bar is just a visual representation of a progress. If you want the user to interact with a slider or with a progress bar, then you need to choose the slider actor. So this is the correct one. And a slider, you always see the mandatory information highlighted in red as well in Scene Composer. It requires a background. So let's quickly add a background, which again is a 9 patch in our case. And we use here the bar frame as a background graphic. Then again, the auto patches, and then just save it. Okay, and the second part when it comes to a slider is that we need then a content in it. So let me make that a little bit larger. So that here we have the background graphic now, and now in it we want to have some bar which is getting filled. And that one is called a so-called knob in Scene2D. And you can have a knob before, so that would be the graphic that is used before the value, so before the knob. Then you have the knob itself. So this is the current value or progress where it would be. And then there's also a knob after, which is the graphic after the knob. And the one that we need is the knob before. And there, let me first of all save this file quickly. And now that might be the first idea that you have. We will use a 9 patch again and load up the bar graphic. Again, some auto patches, usually that simply works. You can also drag around the lines yourself to adjust the 9 patch. But most of the time, at least for me, the auto patches functionality always works. Okay, that's interesting because now if I click here in the preview and drag the bar with it, then it actually looks already correct and how it should look like. But I don't know, maybe that's happening in the scene or when you use it then really in the game. Or maybe we just don't see that here. But trust me, or try it out. When you have then a value of 0 and the knob graphic should not be displayed at all, maybe it's actually there. We just don't see it because it's too small. It's not possible to have the graphic minimized to a 0 width, and you will have here some artifacts, some graphical artifacts here with the 9 patch, because it works when you have a specific minimum size of your texture, so it can be reduced to a minimum amount. Let me open up the drawables and the bar once more. Can we change that later on? I don't think so. And never mind. Let me quickly create here, or let me load it up again. So the bar, you can imagine that this graphic has a minimum size, and when you go below that size in that preview image, I cannot even do that. But obviously for a progress bar, if we haven't made any progress yet, we don't want to have this texture. I want to have it smaller than that. And this is a problem with the 9 patch, that it cannot go below a specific minimum size, and it looks then rather stupid. And the solution to that is then a so-called 10 patch, which we can create here. Out of the 9 patch, we can make a new 10 patch drawable. Again, we use here the auto patches, and we need to click on more settings. And the important part here now is that first of all, the minimum width needs to be set to 0. And we need to enable tiling. So those two things, minimum width to 0 and tiling to on. And then give it a unique name, so bar 10, so that we can then save it. As for example, bar.10.9, whatever. And now you see here we would have this 10 patch graphic available. And for the knob before, we would then, instead of the 9 patch, we need to choose the 10 patch, which works here the same, but I think you can actually see it. It's rather small, but I notice it. When we go to a 0 value there, the graphic really disappears properly and doesn't have some leftover minimum texture pixels. So the solution, and in my opinion, is only necessary with sliders where the content of the slider, or also with the progress bar, the content of the progress bar is not before, which needs to be 0 at some point. There, the solution is a so-called 10 patch. And this class itself was, again, developed by Releus. He made the solution there. I think there's also some documentation why it was introduced, how it works, and so on. So if you want to get more details, just have a look at that. I add the link to the video description below as well. But this is an important piece of information when it comes to progress bars and sliders, that the 9 patches are not the solution to everything. There you really need to use the 10 patches for that specific scenario if you want to scale or draw something with a width of 0 or a width which is smaller than the original graphic width. Okay, so for me, that would be everything related to Skin Composer. And the next thing that I want to show is now the so-called Scene Composer. So let's go there. For me personally, the user interface there was a little bit confusing because the program is the self. So we are still in Skin Composer. And to go back now to skin editing, you need to go to File and Quit. Then you are back to the Skin Composer. For me, that was confusing initially, but now I understand how it works. So, and then going back to the Scene Composer, you click to Project and Scene Composer. So this is how it works. And yeah, what you see there is, as the name suggests, you see a scene, which is basically a stage of LibGDX with a so-called screen viewport, which simply takes up or has the width and height of your entire screen resolution. And here you have a live preview of how your stage, when you call the different add actor methods, how it would look like. And there we are going to design now the main menu. I will not draw everything together with you. I just show you what kind of functionality you have there and how it works. And then I just show you the final result and load the repository stage. So first of all, as a stage in Scene2D, it always has a root element, which is this group. So there's always at least one actor in the stage, which is called the root element of the scene graph. And that is a group, which is simply a group of actors, but that has no visual representation. It's just a container for your user interface elements. And then normally what you do in Scene2D, you work with so-called tables. So let's add a table. And a table is then like a grid. You can imagine it like a very flexible grid, I would say. And there you choose the amount of cells that you want to have in the columns and the amount of cells you want to have in the rows. So for example, let's take a 2x2 grid. So now you see below here always how your scene graph and how your stage looks like. So we have the group. We can select that when we click on it. Then we have the table where we have here the outline of the 4 different cells. And there we can select now the different cells. So for example, the top left cell would be cell 00. And that one currently has no element in it. But coming back to the table, so in Scene2D, all the user interfaces that you're going to create are made usually with tables. And a table is a very powerful tool once you understand it, because it has a dynamic way of laying out your elements. So it calculates the width, the height, borders, and so on of your elements, then places them correctly. You also have the flexibility that we see that in a moment, that a cell can grow on the x-axis or on the y-axis, or it can grow in both dimensions. It can fill up the content, or it can remain with whatever size it has. You can center it, you can align it wherever you want to have it. And with this concept of the tables, you usually then just nest the tables. So for example, let's imagine you have here something on the top left, and there in that specific area, you want to have maybe the attributes of the player. Maybe you want to show the equipped inventory items and so on. And you would then simply in the top left cell of that table, you would add now another table and then define your layout with that. So nested tables are usually the solution in Scene2D to build more complex user interfaces. It's always table inside a table inside a table. And at the end, every cell, so a table always has cells, and in the end, every cell has then one specific actor. Could be a table, which is then a group of different actors, but could be one specific actor like a label or a button, and that would be then the leaf. Let's call it the leaf of this scene graph tree. Okay, we had a button and a label. So let's just do a demonstration on the top left now. We click inside that cell here, and now we set a widget for that cell. And there we will use a button as an example. Then you can give any actor in the scene a name. It's optional, you don't have to do that, but later on we see that in the code. There you have the possibility to identify or get a specific actor by its name. There is a find actor method, and there you just enter the name, and then you get back that specific actor with that name. Then you can choose the style. So we only have the default style. But again, if you would have multiple styles here, you could choose what kind of visual representation you want to have. Touchable simply tells the actor if it can be touched, so clicked with the mouse, or if you are on the phone, if it can be touched by the finger. Visible, if it's visible or not. Checkbox, checked would be for a checkbox button. Disabled, if the button is disabled or not. Can give it a color, a padding, and so on. But these settings here, those are the button-specific settings. And this is something that I struggled at the beginning a lot. You have some padding and sizing information for the actor itself, for the button. And you also have some information on the cell which contains the actor, the button. And the cell is again linked to a table. And just to give you here a demonstration, so a cell is usually used where you define how big is the area that the actors inside that cell can use up. And for example, here for the cell, we can say we want to expand it on the, or let's grow it in both directions. So on the X and Y axis, and also fill the content in it. And what does it do? So now, if you remember, go back to our table, we have 4 cells. And for the top left cell, we now said it should grow. So it grows a maximum amount of size that it has available to still have enough space for the bottom right and bottom left cell. So currently there is no content in these cells, so that's why they are getting reduced to a minimum amount of dimension. But you could of course also have some other information in the other cells, and then this is the power of the table. Then it simply calculates what kind of space is there available, and then it expands the cell accordingly. And since we also use the fill information, it will then also fill the content inside that cell. Then, if we untick the fill option, if we just expand, then you see that here as well, the cell still has the maximum amount of space available that it can use because we said it should expand, but we didn't say that it should fill something. So that's why the button itself simply has the minimum amount of size that it needs to correctly represent itself. Then a cell has an alignment, so we could of course say the alignment should be top, which simply moves the button to the top, top left, left, and so on. So there you have the immediate feedback what the alignment does here. And we can also go back, so we don't expand anymore. You could also set fixed sizes, which sometimes also might be useful. So maybe the width would be 100 pixels and the height would also be maybe 100 pixels. Then you see here, now it has this fixed size instead of a dynamic size. Okay, and last, but that is a more advanced feature, I would say, that would be uniform. It's described here as well. So if you have multiple cells in the table, imagine maybe a login form with username, password below it, and then the input text fields on the right side. With this uniform option, all the cells which have the uniform set, depending on if you want to uniform them on the X or the Y axis, they will then simply have the same size, which sometimes looks a little bit nicer for certain interfaces. Okay, and one more example. So let's go now to the top right cell, for example, and here we add now another widget. Here we add our label. We again use the default style. The text is, I don't know, some dummy text. Then the color, we just have the white color here at the moment, but let's choose the black color so that we see the text here. And yeah, with the label, there are some additional options. So first of all, there would be ellipses. Simply if the text would be too long and there is not enough space available, it will make the text at the end simply with some dots so that the user knows there is more text available, but it doesn't show the full text because there's not enough space available. That would be this ellipses. And there's also wrapping. So if the label maybe just has a width until, yeah, let's try it out. So we set wrap to true, and then the default behavior is that it wraps every letter here because the cell at the moment does not expand and therefore is too small for the text. So it simply wraps every letter here. But if we now say, for example, expand on the x-axis and fill the content, then you see here the text is now correctly aligned and doesn't wrap anymore. So this is, in my opinion, a very good way to create the user interfaces because, again, as you see, you get the immediate feedback what happens when you play with certain cell options and when you play around with certain actor options. So what is happening there? And I think that's it. So just play around with it, design or draw now your own user interface that you want to use for the main menu. And the last thing for the scene composer functionality there is that you can click on File and you can click on Export and then copy to clipboard. And what that does, we don't use that yet, but just that you see it, let me go to the game screen and I just paste the code here below. So what it does, it simply gives you the code that you need to paste to your LibGDX application to create the same layout that you see here in Scene Composer, that you see that then in your game. So it would create a stage, it will load the skin, it set the stage as an input processor, and then it creates, in our case, the table, the button, and the label, uses the different methods to set up the styles, the text of the label, and so on, and adds then these different actors to the stage in the end. And yeah, at the end stage, add actor, the root table, that will then be added. And yeah, this code here that we get, this is, in my opinion, a very good starting point then when it comes to the view implementation or the user interface implementation of your program. So that is what we are going to use then in, yeah, very soon when we implement our own main menu. Good, so let's start now with the coding parts. First of all, I copied over now the UI files and again the raw files from the repository so that we really implement then the menu that you see in the repository in the example in the demonstration. And also I just loaded up the Scene Composer project file there. So this is how the menu should then look like in the end in our game. And just that you see there, it's the same as we have seen before. It's a table. The table has 3 cells in one column. The first cell would be the banner, this Mystic Tutorial banner. The second cell is the menu part with another table in here. So there you have this nested table approach. This table again has 4 cells aligned in a column for start game, music volume, sound volume, quit game. The cell 1, which is this music volume, is again a nested table with 2 cells, the title and the bar below. So just to show you there how this table nesting is working and how layouts are created in Scene2D. So before we start, we need to do some Gradle adjustments because, as mentioned before, with the 10 patch that we are going to need for our bars or for our sliders with the music and sound volume, we need a 10 patch. And to support 10 patches, we need the 10 patch version of the library, which is 5.3. And also we need something which is called Stripe, which is related to that. And there we use the Stripe version 2.0. And the Stripe version is needed for the TrueType font support so that we can load our TrueType fonts and render them properly. And then finally in the core Gradle file, there we simply need some new dependencies that I will now just copy over. So for the free type font support, as mentioned, we need the stripe package, the free type part of it, of the stripe library. And for the 10-patch support, we need the 10-patch library with the 10-patch version, and then update the Gradle project, download the dependencies, and yeah, that is the Gradle update that we need. Then the next thing is, so the first thing that we are going to implement and try that also out is that we create a new skin asset. And there, this is nothing new. It's an asset of type skin. So this is a new class from Scene2D. The skin file itself is called skin.json, and the location is in the assets folder, user interface. There we have the skin.json file, and that's it. The next thing is that in our asset service, here we need to specify now a specific loader for our skin files, because we are using the true type font. So that's why whenever we load an asset of type skin, then we are going to use the free type skin loader, which is from this stripe library that we have seen before. And yeah, the file handle resolver is simply the file handle resolver that gets passed to the constructor. So with that line here, whenever we are loading now a skin, we will use this free type skin loader to correctly support true type font skins. And the last thing would be now in our loading screen. So when we queue the Atlas assets, the sound assets, then maybe below here, we also queue now from our skin asset, the default skin. And the last thing, so now we don't want to go to our game screen anymore. Now we introduce a new screen. For now, it's just an empty one. Let's call it a main menu screen, which takes the game instance as a constructor argument, so similar to the game screen. And in the loading screen, we add the game screen, we add the main menu screen. And when we are done with the loading, then we switch to the main menu screen instead of our game screen. And yeah, so if everything is working, yeah, looks good. We should end up in our main menu screen, which is obviously black since we don't render anything, but we did not crash with the skin loading, which gets loaded now in the loading screen. So the skin loading itself is already working, and now we just need to use it. Perfect. Okay, and just to align it with the repository, it's not called main menu screen, it's just the menu screen. Good, so now the final part, which is now implementing the menu that we really see something. And yeah, so how does that work? There are different approaches when developing user interfaces. You maybe have heard of Model View Controller pattern, MVC pattern, or the Model View ViewModel pattern. And the one that we are going to use is the Model View ViewModel approach, because yeah, I simply like that approach now the best. The way I implement it might not be ideal or according to best practices. I don't know, but it simply worked out for me quite well in the past couple of projects. And it also splits the responsibility in the code very well. So I like that approach. And yeah, so what does that mean? So first of all, the model. What is the model? Because I find this term confusing. But the model is simply your game data. So in our case, it would be the different entities and their state. So for the player, for example, it would be his hit points, the damage that he has, and other things. So that is the model part. Then we have a view model, which is simply a separate class which somehow reacts to game events. So for example, when the player gets damaged or when the player deals some damage. And then internally, it has some logic which might be necessary for the view itself, maybe some data conversion or whatever. And yeah, this view model is simply then a layer in between the model, so your game data, the raw game data, and the view, which is the user interface. And the second part, so model view model, the view is then simply the user interface part, and that one is linked to the view model and can register to property changes. So for example, if the game view model has player hit points as a field, then the game view can bind to this player hit points, and whenever they get updated in the game itself, then the view will react to that and, for example, shows the updated hit points of the player, something like that. Just hearing about it, the theory might be confusing, so that's why we are going to implement some real example. But what we are going to do here in this part, we are just implementing the main menu, but we also prepare already this property binding for the next part where we are going to implement that, but we will not use it in that part. But just that you are aware of that, we implement certain methods which are, in my opinion, useful and nice for the model view model pattern, but they are not all used in that part. That comes then in the next part. So first of all, let's create a new package for user interface related stuff. And also here we want to split between the model and we want to have a view. And in the model package, we are going to implement now an abstract ViewModel class. So this is an abstract class, so you cannot instantiate it because you need to override it then for the menu. We will have a MenuViewModel with menu-specific logic, and for the game ViewModel, for the game we will implement a game ViewModel which has some game-specific logic in it. And yeah, what does that ViewModel need in general? So it needs access to the game itself, because that might be useful if we need to switch screens, for example, from the menu to the game, or in the game when the player dies or whatever, or wants to go back to the main menu. So that's why we need access to the game, and also to have access to some other things like audio service, to play some sound effects when a button is pressed or things like that. And the other thing that we are going to use here is a so-called property change support, which is part of the Java beans, which I use there. And that one is then used, as mentioned before, that the view can react to property changes of the view model. So again, this example, when the player hit points changes, that the view knows about that and can react to that and do something. So the view model has a constructor which always takes the game. And then we assign the game, and for the property change support, we create a new property change support, and the source bean is the view model itself. And then there are certain functions in this property change support, which is called add property change listener, where you can pass in the property name where you want to react to the changes to, and then a listener, which then needs to implement a specific class so that it gets called or can react then to property change events. And the second thing would be remove property change listener, where you simply pass in the listener itself and then you remove it. And yeah, I don't want to have to implement the listener interface everywhere and write the normal syntax there with Java. I prefer more a functional approach, and that's why I implemented there two utility methods. One is called onPropertyChange, which takes the property name. Then it takes the type of property, so if it's a float or a string that we are going to react to, and then a so-called onPropertyChange lambda function, which again is very similar to a consumer. And then the view can simply call onPropertyChange, for example, playerLife, which is an integer.class or float.class, and then in a lambda function immediately specify what should happen in the view. It makes it, in my opinion, a little bit nicer to write down with the functional syntax. And yeah, this onPropertyChange is then again a functional interface. And it has one method onChange, which takes in a value, which is the updated new value of the property. And in here, so how does that work? From our property change support, we add a listener with the property name, and we get then an event, as you see, a property change event, and then simply from that lambda function that gets passed, we call the onChange method, and with the property type that we pass in here, we cast from the event the new value, which is a generic object, and yeah, we cast it to our type, which would be a float or a string or whatever. Makes it a little bit nicer instead of writing this piece of code everywhere. And the second function is simply the clear property changes. And there, what I simply do then from the property change support, we can get all the different listeners. And for every listener that we have here, we can remove the property change listener. So this is some cleanup functionality to don't have some leftover property change listeners. And yeah, again, this functionality here, those two methods are not used in that part. They will come in the next part with the game user interface. Okay, so this is our generic ViewModel class. The next thing that we need is the generic View class, which again is an abstract class, and it's a generic class which is of a specific ViewModel type, because as mentioned before, a view is always linked to a specific ViewModel. But also to know in this pattern, the ViewModel itself doesn't know about the view. So it shouldn't directly react with the view because it shouldn't care how things are represented in the user interface. That's why it needs to provide this property change support so that things like the view can react to certain things, but without the ViewModel knowing what kind of things are reacting to it. Good. And in addition, a view is always a table in Scene2D, as we have already learned it. And I think that's it for now. And yeah, the view needs access to the stage. The view needs access to the skin itself. And the view needs access to its ViewModel. Okay, and what I like to do, so when a view gets created, then at the end, I wanted to have a separate method where all the user interface code ends up, so that the table creation with the different actors, and I simply called that setup UI. And that is then simply an abstract method, which returns nothing and needs to be implemented by the specific view implementations. And then one special thing, we need to override the set stage method, because that's a little bit similar to what we had in Ashley's system with the engine. The stage is not available in the constructor of a view. It gets set afterwards, and there we need to do certain things. So if we would remove the view from the stage, in that case, the stage is null. And if the stage is null, then from our ViewModel, we need to clear the property changes. So if there would be changes, that the view doesn't react to it, because yeah, it's not part of the user interface anymore. It's not linked to any stage. So that's why we remove it. And otherwise, when it gets added to a stage, then we also call a separate method that I called set property change. Set property changes. And that would be the method. It's a protected method. And in that method, you would set up the property changes to the ViewModel. We already make a default implementation here because maybe not every view needs to be linked to certain property changes. So that's why it's optional. But if you want to use it, then you can override this method here. And yeah, that makes it very clear and also differentiates nicely between the user interface functionality part and the property change part. Okay, so that would be our base classes. Now we need to implement our real MenuViewModel. And any specific ViewModel extends our base abstract class, the ViewModel. And in that specific case, in case of the main menu, there we want to have the access to the audio service. And what do we need in our main menu? So we need access to the music volume. We need access to the sound volume because that is what is shown in the sliders. And we also want to set the music volume and set the sound volume. So the first one would be get music volume. That can be called by the view initially to get the initial value, and that simply returns from our audio service the music volume, and same for the sound volume. Okay, then another method would be the set music volume. There, simply from the audio service, we set the music volume and the volume. And the last method would be set sound volume. And there, from our audio service, we set the sound volume. Good. And the last thing, when in the main menu someone clicks on Start Game, then from our game we switch to the game screen. And also, if someone presses on the Quit Game button in the user interface, then we call gdx-app.exit, because that one is closing a running GDX application. And yeah, that's our menu model. So there you can control the music and sound volume, you can start the game, and you can quit the game. And the last thing would now be our MenuView, which extends our view class, and it's a view of type MenuViewModel. So we need to override the setup UI. And we also need to override the constructor, which takes a stage, the skin, and the view model to properly call the view constructor here. Good, then for the setup UI method, so there we go back now to Skin Composer, to the Scene Composer area. And before, as mentioned, we go to Export, copy to the clipboard, and simply paste the code now inside this method. And yeah, what we need to do, so stage, skin, and processor creation, that is not necessary in our case because that is handled by the game itself. And also stage add actor at the end, that also needs to be removed because that is handled from the outside. Then the table here itself is not a new table, because if you remember, the view itself is a table, and that would be our root table. So from that copied code, we remove the table here, and then everywhere where we have table dot, let's select all these areas. We remove it because we do that on the view class itself. And now let's go through it one by one. So the first thing is set fill parent, which simply tells the table, so in our case this view class, that it should fill up the entire space of the stage so that it correctly gets stretched across the entire screen. Then we add the banner image to it. So we add the image, and we call row, which is a method of the table and indicates that we are at the end of a line and want to go to the next line. So let's group that here together. And we can also just make that in one line. So coming back here, we have the banner image added here. And when we call row, then we go to the next row of our table, which would be this one here. Then we have all of that stuff here down to here, which is linked to that content table here in the middle. And the last piece would be then this by Quillraven yada yada, this little text at the end. So let's select again the entire code here and extract that into a new method. Let's call that setup menu content. And finally here we can do some minor code cleanup. So we have here the label, this by Quillraven. The style name is, so how does it work? I think we never used it. That's the first part. I should explain that a little bit. So first of all, an image in Scene2D is, as the name suggests, just an image. And since we are using a skin, we pass the skin to this class and give it the name of the drawable so that this proper texture is then rendered. And what is the name of the drawable? So in C, let me quit that here. So going to drawables, there you have here the name banner, and that is simply that texture here, this Mystic Tutorial texture. So from the skin, we get the drawable name. Then the loading is done with the skin. We get back this image actor, add it to the table. Then we have the entire menu content. We go through that in a moment. And at the end, we have a label, again with a text. We pass in the skin. We pass in the style of the skin. So there I have the small style with a little bit of a smaller text. From the label, we set the color, which we also get from the skin via the name. And then we add the label with a specific padding. We expand. So whenever you call add, as you see here, you get back the cell of the table. And from on the cell, we set the padding. We say that the cell should expand on the x-axis and that it should align on the bottom right. So this is how that is working. And yeah, let's go through the menu content once more. So let's rename that to, that one is the content table of the menu. It has a background graphic, which is a drawable again. This is how it's called in Scene2D with the name frame. We have a specific padding. We have the text button start game. Then we have a little bit of repetitive code, let's call it like that. That would be for the music slider. So we have a label. Let me go back to the scene once more. So we have a label which would be music volume and below the slider. And then we have another title with sound volume and then the slider below. And yeah, this is that part here. So there's a table with a label. There is in here it's a progress bar, but we need to change that because in the scene composer file, I used a progress bar, which is wrong. It needs to be a so-called slider, which is the same as a progress bar, but again, it has a difference that you can click on it with the mouse and interact with it. So this piece here is a little bit of duplicated code, copy and paste. So we will refactor that. And finally, we have the quit game text button. And that's it. So let's refactor the parts here. So we can get here a slider. Let's call it the music slider and create a new method, set up volume slider, which takes the table where it needs to be added. Then a title, which would be music volume in that case. And there is a starting point. Let's copy that code from over there down below. So we will have a surrounding table. Then we will have a label which with a specific title. Then we set the label color to sand, a specific color. And then we add this label to the table and call row. And down below here, so we don't have a progress bar. Here we have now a so-called slider. With a minimum value of the slider 0, maximum is 1. And the step size is 0.05. So that is linked to our audio service for the volumes. If you remember, we have values between 0 and 1. And we step by 0.5 when we interact with that slider. And yeah, it's not a vertical slider, and we need to pass in the skin again. Finally, we add the slider to the table. And we add the table to the content table itself with a padding of 10. And then we call row. And at the end, we return the slider. And now up here, we can simply call here set down volume slider for the music. And another call to that method for the sound volume. And let's also move the row up there to make it a little bit shorter. So currently we don't use these sliders here yet, but that comes then in a moment when we also come to the final part to integrate the keyboard controls and the mouse controls to do something in the menu. But yeah, that should be sufficient for the menu. So coming back now to our menu screen, we now want to add this menu view to our menu screen. And currently there is no implementation, and there is nothing new that you learn from whatever we are going to implement in that screen. So I just guide you through the final code. So that's the basic setup of the menu screen. So we get the game instance. Again, we create a user interface viewport stage like we did it for the game screen. In the resize method, we want to update the UI viewport. In the show method, we set the input processor with the stage. In the hide method, we clear the stage. In the render method, we have the stage rendering as we have seen it also in the game screen. And we dispose the stage here. And what we are missing now is that we need to create this menu view. And we can do that here in the show method. So there we finally call now this add actor method. And the actor that we are going to add is our menu view. That takes the stage as an argument. It takes the skin as an argument that we get from the asset service here at the top. There we get our default skin. And it needs a view model, which is our menu view model. And that one simply takes the game instance. So now if we load the game, we should see, perfect, we should see a menu now available. So we have our banner, we have the menu there. There is no selection image or whatever you saw in the initial demonstration of this tutorial series because we haven't added that yet, but the graphical representation of the menu is available. And also when we click inside the sliders, there you can see that something is already happening. Good, so we have the graphical representation of the menu, but nothing is happening yet because we haven't implemented that. So let's go back to our menu view. What we are missing is now the different event reactions when someone is interacting with the actors. And there are again different methods. So for a text button, for example, there is a click listener, or is it called add listener, I think. And there you just add then a new click listener from Scene2D. Then there is also something when you enter with the mouse a specific area. Then there is something on the slider when you change the value with the mouse. So to the different things where you can interact with the user interface elements, there's then also some way to react to that. And again, I don't like to write this add listener codes with listener methods and so on in it. I prefer the functional way of programming. So that's why, similar to the view model, we add some utility functions to our view. And the first one is called onClick. It takes an actor, and we define it also in a moment, a so-called onEvent consumer. And what we do here, so from the actor, we call add listener, we add a new click listener. And there we override the clicked method. And inside here from our consumer, we call the onEvent method, and that's it. So how does that look like? So again, it's a functional interface, which is called onEvent consumer. And the only method that it has is onEvent. So this method we can use, for example, to buttons where we just want to know when a button gets clicked. Then we can make it we can call onClick and then add the logic directly what should happen when a button gets clicked. The same thing, let's copy that over, is called onEnter. So when we enter a specific, when we enter the area of a specific actor with the mouse, so there we can make it generic. So it's an arbitrary actor T, and there we have an onActor event that we are also going to define in a moment, which is again a consumer. And here we add a so-called input listener. And we override the enter method, where from our consumer we call onEvent and pass in the actor. And again, it's a functional interface, which is called onActor event, and it's a generic functional interface of any actor in Scene2D, and it has an onEvent method, which takes the actor of type T. Good, and the last utility method is the onChange method. And there, instead of an input listener, we have a so-called change listener. And there we override the changed method, where again from the consumer, we simply get then the actor. And let's rename that one here because we pass in the actor that gets passed in here in the function. It's the same one here below, but to avoid the cast, we just pass here the generic actor already correctly. Good, and coming back now to our menu view. So the first thing here with our text button, what we can do now, we can create an on-click from our text button. And there, when it gets clicked from our view model, we just want to call the start game method. And in my opinion, writing it like that is easier to read and also shorter to write. So that's why I add these utility functions to have that available and easier for the future. Then below here, it's the same. So on click of that specific text button, and there we call from the view model the quit game method. And finally here from the music slider, we have the onChange utility method. We pass in the music slider, and then we get called with the slider that we have. And in our view model, we call set music volume and pass in the value from the slider. And exactly the same with the sound slider, where we call the set sound volume. Okay, then coming back to our menu screen, I think if we call here now, if we play some music, we should be able to already control the music volume. And one more thing in the menu view, we forgot that. So from our music slider, the initial value is from the view model, the get music volume, and from the sound slider, the initial value is also from the view model, the sound volume. Okay, let's see. So hopefully that works already. So we hear some music. And the controlling is working. So when I go down to 0, the music is off. When I go up, then the music is a little bit louder. I can also just click somewhere. For sound, I think, we haven't implemented that some sound effect is played. So we don't know if the sound volume really changes, but most likely it does. And finally, when we click down one of the buttons with quit game, the application shuts down, which is good. And when we click on start game, we get to the game screen. So all of that is working as well, which is perfect. I think we now just add one final part, which is important for Scene2D, which is actions. There we are going to implement a selection image. So when we hover over a specific element here with the mouse, then it gets highlighted. With some selection image, we add some actions, which is, in my opinion, the last important piece of information that you need to know about Scene2D. In the final repository, there is also the controls added for the keyboard controller, where, if you remember, we had a UI controller state. Did we implement it like that? Or at least we have a game controller state. Let me look. Then we have an idle controller state. Okay, and in the repository, there's also then a UI controller state, which takes then the stage, and then simply from the stage, it fires certain events. The view is reacting to these events, and then something is happening. But in my opinion, this is nothing where you would learn something new. So I don't show that to you. I show it at the end of the part with the final code to explain it to you, but we are not going to implement it live. What is more important for you, where you learn something new, is from the menu view that we add now this selection image. So what we need an image, which is our selection image that we are going to show. And we also need to reference what is the currently selected item in our menu. The selection image itself is simply drawable. So from the skin, there we have a selection image available, and we don't add that yet to the stage. We do that later on. And also this selection image we set it to touchable disabled because it's on top of our button. And if you would click it, if the player would click it with the mouse, he would then always click on the image and not on the button below. And by disabling that image, then it doesn't react to click events, and therefore it doesn't block the button from getting clicked with the mouse. Then before we continue here, what I like to do is to add an enumeration for the different menu options that we have. And the options that we have is Start Game, then we have Music Volume, then we have Sound Volume, and finally we have Quit Game, so that we know and somehow track what is the current selected menu option, to also know then in the input handling methods what kind of function on the ViewModel should be executed depending on what kind of menu option we have. This is important when it comes to the keyboard controller handling. So going up here, we initialize the selected item, and this is simply this find actor method that I also mentioned somewhere before, where you can give any actor a name and then call this find method to get the actor. And we simply get the actor which has the start game name. And finally, we call a new method which is called select menu item. And there we pass in the currently selected item. This is then the menu item, this group here. And yeah, what do we do? So if the selection image has a parent, so the selection image will be added to the button, for example, of Start Game, or to this music slider table, and it will be simply then on top of all these actors. So if it's currently part of any menu option, this is the get parent not equal null, then we get the parent and we remove the selection image from there because we want to change it there. Then we update the selected item, which is then the menu item which gets passed in here. And finally, from that menu item, we will add the selected image to it. And we are going to make some animation. So from the selected image, first of all, we clear any actions which are currently added to it. And finally, we are going to add some action. So action again is used to make some animation or some effect in Scene2D over time. And there is a so-called actions class, which provides already some utility functions for commonly used actions. One of these actions is forever. So it simply repeats whatever action I define now forever until I stop it or remove it. And we are going to define a so-called action sequence, which takes in an arbitrary amount of actions. And the first action is a parallel action, so two actions that run or are updated in parallel. The first one is a size by, where we increase the selection image's size by a specific value on the X and Y axis. Then we do that over a specific time, and we use a specific interpolation, which in that case we use a linear interpolation. And also we move the selection image by half of its extra size. Also over the resize time, and we also use a linear interpolation. Okay, so the extra size and so on, these are simply some properties up here. So the extra size, so how much does it grow? It's 7 pixels. Then half of the extra size is simply the extra size multiplied by 0.5. And the resize time, so how long does it take? This is simply 0.2 seconds. Good, and since we have a sequence, so what is happening after this first parallel action? When that one is done, then we have another parallel action. And here we simply resize it backwards. So we remove the extra size from it, again with a linear interpolation, and also we move it in the opposite direction again. And finally, so before we make here a call to clear action, also from this selection image, we set the position, which is -half the extra size. And we also set the size, which is from the menu item, the entire width plus some extra size, and from the menu item, the entire height plus some extra size. Explain to that in a moment when we see it. Why do we need to do that? The reason could be that we are in the middle of one of these actions and maybe just by half the time where it's currently increasing in the size. And if we would change now the selection to a different menu item in the middle of the animation, then the new starting point of the size increment and the moving would be the current position of the selection image. And since that one already got scaled, at some point we would simply offset it and it would move out of screen or something like that. That's why we need to properly reset its position and its size before we start the actions. And the actions itself, they are getting updated, if you remember it, in the menu screen. In this act method of the stage, there, all these different actions and how they are implemented in the background, they are getting updated via the delta time. Good, so the only thing that we need now is to find this actor with the menu option start game. So here, from this text button here, we set the name, which is the menu option start game name. And also what we need to do now, we need this onEnter method from our text button. And then we call the select menu item whenever the mouse enters the area of the start game. Then in here in our sliders, we also need to pass in the menu option. That would be the music volume. Here we would have the sound volume. Then here on this table of the slider, there we set it, the name of the menu option. And also down here, we call onEnter of this table of the sliders and again call this select menu item. And the last thing would be with the quit game button there, again, menu option, quit game name, and also onEnter of this text button with select menu item. And yeah, let's see if that works. Looks good. So we have here this selection image, which gets resized over time. When I move with the mouse over the different menu options, the selection does change properly. And we can still click on the buttons so they react and the selection image does not overrule the click event of the button. Yeah, coming back to the actions, because that was the important part here. So how does it work or what does it do? So we have a forever action, so it runs forever until we stop it or remove it. And we have a sequence of actions. And the first action is resizing the image, and also it moves the image a little bit, because when you resize, again, it goes from the bottom left corner, it would simply go up and down like that. And with the move by, we adjust that. I will comment it out in a moment, then you see the difference. And the second action, so when the increase of the size is done, then we move it back to the original size, which is happening in the second action. And then, since it's a sequence and since it's forever, it simply repeats that part over again. Okay, so just that you understand what this move by is doing, let me quickly comment it out. So there you see now the bottom left corner remains the same, and it simply scales upwards and to the right. And yeah, that looks a little bit stupid. That's why we are moving it also a little bit to have a real selection feedback in the user interface. And yeah, that's it. That was a complete example of a menu with mouse interaction and so on. And as mentioned, the property change part with GameView and MenuViewModel will be implemented in the next part when we are going to implement the text system and so on. The only thing that I want to show you now is the keyboard control handling, because that one we are not going to implement now. It simply takes up too much time. And as mentioned, you won't learn anything new from that. So it's not that crazy or fascinating. So the way it works, let me zoom in here, is that in the view class that we have implemented there are methods on left, on right, on up, on down, and on select. So that would be when we press the left, right, up, down, or select button on our keyboard, then these methods of the view get called, and then simply in the implementation of the menu view, for example, there you can then see, so when the down button is pressed, we get from the currently selected item the group, so the menu content table. We check what is the index in our menu options and so on, and go on to the next group. So there's then the logic in on down, on up, on right, on left, and on select, what should happen. And that's why we needed this menu option, because when we just work with the mouse, then it's clear what kind of actor we have clicked and where we are currently located. But when it comes to the keyboard, we somehow need to remember what is the currently selected menu option, and that is then handled here. And yeah, in the end, in the menu screen, you just would need to add a keyboard controller, which has this UI controller state. And in the input processors, additionally to the stage, you also need to add the keyboard controller there. And the last piece of information that you need to see and know would be then the UI controller state, which is nothing fancy. So it takes the stage, and on the root element of the stage, we fire a so-called UI event. This is a custom event implementation by me, and it takes over the command. So this up, down, left, right command, and the view itself is then simply handling those UI events. That's it. So there's a generic, I think it's called handle event or something. Let me check. The input listener interface or class in Scene2D has a specific method that you need to implement. It's called event listener. So when we call stage fire, then we need to implement this event listener, and there is a method which is called handle, and there you see, so I then get our custom implementation of the user interface event, I get the command, and depending on the command, I then call the specific methods of the view, and yeah, that's it with the keyboard controller handling. Good, yeah, that was a rather long part. I hope you liked it. I think the Skin Composer tool in general helps a lot when it comes to creating user interfaces, and I hope that helps you as well. Then thanks for watching and see you in the next part. Bye bye.